Alright, hi folks, we're back with extra calorimetry problem number 2, which I think is a bit easier than the last one. It says a calorimeter is filled with 167.03 grams of water at a temperature of 16.3 degrees Celsius. A substance with a mass of 133.28 grams is heated to 100 degrees with 4 significant digits Celsius in boiling water and dropped into the calorimeter. The final temperature of the substance and the water is 27.8 degrees Celsius. So we can also fill that into the water because remember, at the end of a calorimetry experiment, everything should be the same temperature. So it wants us to find the specific heat of the substance. So here's our goal, C, the specific heat of the substance. We can easily find the change in temperature for both the substance and the water. So here, T final minus T initial would be 27.8 degrees Celsius minus 100.0 degrees Celsius. That is a negative 72.2 degrees Celsius. They're significant to the tenths place, so the answer also is. For the water, we have final temperature minus initial temperature, and that's a positive 11.5, oops, watercolor is purple, positive 11.5 degrees Celsius. Okay, so the first on your worksheet says, what is the specific heat of the substance? We will try to find that. Now, what do you think the substance is? Once you see the specific heat, you can consult the table of common substances specific heat in your book, and I'll tell you at the end what it is. And then we're supposed to write our equations down. Our main equation for calorimetry, Q, the heat, is equal to mass times C, specific heat, times change in temperature. So we look at what do we know the most about. We know the most about the water in this problem, so we'll start by finding the heat gained by the water. So the heat gained by the water is the mass of the water, 167.03 grams, times specific heat of water, you need to memorize 4.184 joule per gram degrees Celsius, times the change in temperature of the water, 11.5 degrees Celsius. Plug that into our calculator and we find Q for the water to be a positive 8,040 joules. We look at significant figures, 5 here, 4 here, 3 here. We have to round to 3 significant figures, which we did here. So for water, the water gained 8,040 joules of energy from the substance. And in this case, it's not a metal, just so you know that everything that is a pure substance, an element or a compound that is well, a pure substance, everything has its own characteristic specific heat, not just metals. Okay, so now that we know Q of water, our other important calorimetry equation, all of the heat that the water gained came from the metal. That's heat that or the substance, in this case, not metal. Everything that the water gained is energy that the substance lost. So if we know the water gained 8,040 joules, and we're ignoring the calorimeter itself in this problem, then we also know that the substance must have lost 8,040 joules. So we can find now the specific heat of the substance using that same equation, Q equals M times C times delta T. Q of the substance is negative 8,040 joules. Mass of the substance, 133.28 grams. C is our goal. We don't know what it is. That's our unknown. And then our change in temperature, a negative 72.2 degrees Celsius. The amount of temperature that the substance lost. Okay, so we solve for C. C C equals negative 8,040 joules divided by 133.28 grams times negative 72.2 degrees Celsius. So we see that we have a negative in the numerator, negative in the denominator. We'll end up with a positive, which is good. All specific heats are positive numbers. Our specific heat will be, when we plug that into our calculator, we can have 3, 5, 3 significant figures since we're multiplying and dividing, and that is 0.836, our units, joules per gram degrees Celsius. If you look at your chart of common specific heats, you'll find that this is glass. That's very close to the specific heat of glass. So our substance was glass. And then it says, well, that's all. Try to identify your substance. So have a good day.